Welcome back. Okay, last time we did differentials, and this time we're gonna add it back together. Actually, when you look at this adding up together business, it's not that hard. Differential is, say we have a circle, right? We have a circle. Anyway, we use this side of the circle, okay? So that part doesn't matter. We have a circle, right? Differential is we separate that into small parts, right? One small part, another small part, so on and so forth, right? And then that's called differential. And every part is this side is, let's call it dx, right? This is r, obviously radius, and that's an infinitely small slice. Dx is a straight line. Yeah, when it's infinitely small. Infinitely means small means you give any small number, that number, infinite dx is smaller than that, just not zero. It's an existing number. Yeah. So when we look at every segment of this, it is it's a straight line. Okay. We add these straight lines together. When r is equal to 1, well, when r is equals to r, we go around that, how long dx added up back together is
2 pi r.
2 pi r, right? Right?
Yeah.
Okay. This is done by a computer. Okay, now let's integral is added back together, because we're not going to add the circumference. We add something else. Let's add the area. Let's assume this is the way it is, right?
Yeah.
We look half of it. Let's do this. We look half of it. We keep cutting that way and this way. Okay, this way we cut. It's a triangle like this, right?
Yeah.
Then we take the other half of it. As we cut this way, we're gonna cut this way. Same number of slides, whatever, right? There'll be another side. That one I'm gonna put it upside down, right?
Yeah.
This is dx from this side. That's dx from the other side. I'm just keep doing it all the way down, right, till the last one, right? Since dx is infinitely small, this is vertical anyway. This is perpendicular anyway, right?
Yeah.
So dx is infinitely small. Following? Okay. So how long is this?
It's
From here to here.
It's pi r.
Pi r. And how long is this?
It's r.
It's r, right? This is the diameter. I mean, yeah, radius, right? Yeah. So what's the area of this?
Pi r square.
You see it?
Yeah.
So the area is pi r squared, right? Right?
Okay.
But when we do calculus, it's a little bit, sort of easier than this, and we don't have to deal with it. So we just say every slice is r, right? R dx, and then because it's a triangle,
It's
half of that, right? And we're gonna add all this together. They're just the mathematicians doing things. We call sum it up. Okay, that's the sum. Okay, it's from 0 to 2 pi. That's angle. 0 to 2 pi all the way, right?
Mm-hmm.
And wait a minute. Yeah, right. Okay. The dr. Yeah, right. Okay. Now, we know that constant you can take it out, right? So constant half r, take it out, and they're gonna do dx from 0 to 2 pi.
Yeah.
Yeah, that just added. Actually, that just added up, right? That's the is dx. What's the integral of dx?
Integral of dx. Isn't it just like
Just
that?
x, yeah, just x. Just x from 2 pi. It's x 0 to 2 pi. So that's half r 2 pi. I mean r 2 pi minus 0. that's pi r. Obviously, this is. Oh no. Okay, this dx is really because the we talk about 0 to 2 pi, right?
Yeah.
That's what we're talking about, the angle. When we're talking about the angle, this is really r dx. You get what I'm saying? The angle, right? Is this length?
Divided by.
Yeah. Theta is, this is x. This is theta. So from 0, right? This length is really x times dx times r. This is r, right? So this is dx. Get it? So this is not dx, actually dx times r. So there's another r here. When it comes out, there's another r here, another r here, pi r squared. Yeah? Okay. Now, when we do, okay, this is, of course, I'm not explaining this very clearly. We're going to do it now here. Of course, you can do the, when you do the integral, you can add them back up together. Do we want to do this? Maybe I can do it very quickly. Let me see what time it is. Okay, there's only 6 minutes. I can do it very quickly. This is fx, right?
Yeah.
So this is x. This is causes x. Then next lies is x plus dx. Next is x plus 2 dx, so on and so forth, right? To x plus n dx. N, of course, is well, when dx is infinitely small, and dx is infinitely small, n becomes infinitely big. But that doesn't really matter for us. So we want to calculate the area. Yeah. N dx is a fixed number. So x plus n dx becomes some fixed number. Because when we look at this, we want to, let's call this as A, this is B, right? We want to calculate from A to B.
Okay.
Right? Let's say, okay, this is, let's look at this area. This area is, this is fx. Yeah? This area is fx times x. Let's do this, fx times dx, right?
Yeah.
This equals to, this area is let's just say fx times, yeah, fx times dx, right? Then this one becomes this one becomes fx, let's see, f dx fx. How does this work? So fx plus 2 dx. Okay, I'm gonna cheat a little bit. Okay, let's say the big fx, right? You take a derivative that becomes fx, right?
Yeah.
So what they're talking about is big fx plus dx minus fx divided by dx equals to fx, right?
Yeah.
And it's fx plus dx minus fx equals to fx dx, right?
Yeah.
So at this point is fx dx, right? This is this area. So fx plus dx becomes fx plus dx becomes this will plus another one. This will go up another one. In other words, fx plus dx dx. This becomes f plus dx. So this is fx plus 2 dx minus fx plus dx. Right? I'm just rewriting this thing. Put x as x plus dx. So I'm going to do one more step. Fx plus 3 dx minus fx plus 2 dx equals to fx plus 2 dx. Get it? So I'm going to go down. Fx plus, this will be n plus 1 dx minus fx plus n dx equals to fx plus n dx. Right? You notice this and this will cancel out. When we add all of it up together, this and this will cancel out. This will cancel out. All cancel out. The only thing left is this one and this one.
Yeah.
And we say this one equals b and this one is a, right? So what we have is fb minus fa, right? Equals to, we add this up. We're just gonna write it up as integral as here. We're gonna just use this notion. This is fx dx will go from a to b. You following?
Yeah.
In other words, if I have a function fx, right? I want to get the area under it. All I need to know is the integral of it. In other words, the reverse derivative of it. And all I need to do is just the big F b minus big fa.
Okay.
So when we write it, we write this way: fx a to b, right? This is the notion from a to b. We're doing this big F a to b, and then we write it f b minus fa. Make sense?
Yeah.
Okay. This is the stuff we just did. Right? It's basically this. Okay. Now this is somewhat complete, right? This logic. Okay. So let's see what we're doing here. Okay, yeah. We do one quick example. Let's say a curve. Let's see, move this out of the. See a curve, right? What's this curve?
It's a parabola.
Okay, y equals to
X squared.
x squared, right? We want to do it from 0 to 1. Let's say from 0 to 1, right? 0 to 1, like that, right? You know this area is less than half.
Yeah.
This whole area is half, and then you draw a straight line. There's a piece that's not there. We just want to find out how much it is, okay? So we're going to take an integral of x squared dx from 0 to 1.
Okay.
Yeah. And we know that x to the power n is nx to the power n minus 1, right?
Yeah.
So we put the n over, right? If we want to integrate n minus 1 become this. Okay, so we change this. If this is n, then it's n plus 1, right? We just change the variable. Okay, we shift n a little. Okay, so this x2 then becomes 3, right? Is 1/3 x to the third 0 to 1, right?
Yeah.
And then that's 1/3. Okay, 1 is 1, 0 is nothing, so it's 1/3. In other words, this area is 1/3. You draw a straight line, this is 1/2, right? This area, shaded area, is 1/3. Let's see. What do I have here? Okay. Okay, I can't read my notes. I don't know what I was trying to do here. But anyway, let's move on. Once you have a curve, what you want to know very often is the average of it, right? An average is this area divided by this x segment, how long the x is. Let's say this uniform or whatever. This is the density kind of situation, right? When you have barcode and when the bars are close enough, then it becomes a curve, and you know that, right? So y average number is x dx from a to b, then you divide it by b minus a, right?
Yeah.
Then there is a situation that you want to find a medium. This is all the people that they make money. Actually, it doesn't look like this, but let's get a little bit more real, okay? I think this is a Hong Kong survey or something I've seen. This is all the population. You divide it up. This is the money you make. This is how many people making that kind of money. Then there's some people that don't make anything. Then people start to make a minimum wage. That's government. That's government enforced the jump. Otherwise, it'll be gradual. But the government forced the steps. Otherwise, it'll be like this. But anyway, and then people are gonna make more. Immediately make more, and then there's a whole bunch of people making a certain amount of money. Then at a high amount, then people start to drop. Actually, people are going to drop a little bit. Then it actually go back up. Actually, no. Go back up and then come back, and then come back down. People then come back down. Actually, there's a long tail because there is a few people making a huge amount of money. Right? This is the money. This is people. How many people? Okay, something like that. Okay, you want to know the median earning. What's the medium people make the earning?
Like,
So that's the middle people. That's the think about this as an area, right? Every little area corresponds to a person, right? If another person making this money, you add it up. So if everybody taking an area, this is like all the people fill this area, and this is the money to make. In other words, you want to find a line, okay, that this area and this area is equal. Let's call this A, call this B, and call this X, okay?
okay.
This is fx. So now you want to find the place from A to X is equals to X to B. Of course, this is kind of bad, right? Because you have X in both places.
Yeah.
So you can just do, because you know this is equal, right? You can just do half from A to B, right? You can just say the whole area, this is the half of it. This is the number, okay? X is going to get integrated out. This is the fixed number. And this is going to be just whatever you calculate. Okay, I'm gonna have to take a real example. I'm gonna take this real example because okay, I know this is okay. This is a general comment to everybody. If you feel dizzy at this point, just go back and watch this video again. The way to watch it is first you make sure every step you get the logic that we were doing, and then do it again until you get the drift of it, until you feel this is not that hard. That's why we have a video. Okay. We we are experiencing a air pressure as we sit here. You know how the air pressure come to us?
Gravity.
No, air. Well, yeah, it is gravity because the air is pulled by the gravity. But it's really
Science.
what does that mean?
I don't know.
Let's say, you'll be in water, right? When you dive in, you feel the pressure in your air, right?
Yeah.
What is that pressure called?
Like all the weight.
Right. the water above you, right?
Yeah.
The weight of the water above you, right? As you go deep, then more water, and the water is pretty heavy stuff, and the press on your eardrum lets you feel the pressure, right?
Yeah.
So let's look at that situation, okay? Let's say this is y. Why did I use y? I don't know, but anyway, maybe this is vertical. Okay, let's call this y, right? This is vertical distance. Okay, we look at two layers of this. We call this y. This become y plus dy. Okay, that makes sense, right? Then the pressure becomes pressure here is y plus dy. This is pressure y. By the way, this is xy thing, just random thing. I probably should say fx. This should be y, and then the y should be x. You get what I'm saying?
Yeah.
Normally you say f y plus f x plus dx equals to y, right? But you gotta be free about these things. This is just a variable, just a symbol. You can use anything. But since we're doing what we're doing, please use xyz as a variable. Don't start to write dAs, because dA kind of equal to 0, because a is kind of used as a constant. So the pressure here basically is the pressure here plus the stuff here, right? That's d. Let's call it the mass here is dm, right? The gravity is dmg, right? Okay, let's look at this. Let's look at this the thing. Let's look at a particular area. In a particular area, right? A, right? The pressure times this area, right? Let's look at this. It's actually a cylinder, right, with an area, right? This is a cylinder. That side you cannot see. Yeah. So we look at this cylinder. This area is A, right?
Yeah.
So the force on this is P y plus dy times A. That's a force, right? The pressure times the area.
Yeah.
Yeah?
Yeah.
This force plus dm, right? This is the mass here, right? And then, of course, there's gravity pulling it, right? Equals to Py times A. Okay? But the mass, what we're talking about, let's say the air density is rho, right? Those Greek words, right? Rho times this volume equals to dm. Rho times volume, this small volume, equals to dm, right? And the volume equals to A times dy. Volume equals A times area times this height.
Yeah.
Right? So equals to dm, right? Okay? So I'm gonna put it back in here. So this becomes rho A dy g, right? We'll put a constant in front of, so in case you well, it doesn't matter actually, but in case you messed up, dy you put it at the end, so everybody know this is just dy, not dy something. You see here's the A, here's the A, here's the A.
Yeah.
We take the A out and put this back here. Now you have Py plus dy minus Py equals to G rho A. A is cancelled out, right? A is cancelled out. Dy, right? You put the dy over, so is Py. I just write a little more. Py dy equals to G. I don't know. Yeah, we'll write M in front, G. See that?
Yeah.
So in other words,
Okay.
and rho is a fixed number. So this is a wait. P. There's something that's wrong here. This is the pressure times, this is the force, right? Pressure times the area is force. This is mass mg, that's a force. And this is pressure times the area, that's a force. Well, obviously, it should be the other. Yeah, right. This is higher. The y points down. Y points down. So dm is 0 dv. dm is OA dy. Let's see. Do you see the problem here?
No.
Okay. mg. Pressure here positive, and you put it back in here. This is dy. Rho times g. Oh yeah, right. I see. The rho is the variable. That's proportional to g. Okay. Rho is a variable. That's I wrote the problem is as the air is not consistent. More when you go higher up, the air is less condensed. In other words, the air density is a constant times the pressure. The more pressure, and then there's more air, more mass, or more dense. So this comes to a constant. Let's call it K. Let's not call it constant. Let's call it C, right?
Yeah.
It's C times P, pressure, times G. Okay.
Okay.
And obviously there is a because my y is pointing down. There's there also a negative sign here. Yeah. When y is pointing down, my dy should be negative. Yeah, so this is negative, this is negative, this is G is positive, C is positive because where y is coming down, right? So G is coming down anyway, so it doesn't matter, right? So this comes to P equals to a minus constant P. Okay? Now we're going to write it in a way that we like. dy dx equals to minus cy. Okay? And we're going to drop the, we'll just keep the constant. So we're gonna try to solve this problem. Okay? Dx come out, dy, we want to put x on one side, y on the other side. So this is dy, y equals to minus c dx, right? So this, what's this integral? 1 over y dy.
What?
What's integral of 1x dx.
That's log x.
Yeah, log y. Which is this is y just for some reason. Oh yeah, x is here dy, right? Minus equals to minus cy, right?
Yeah.
There's constant. We're not gonna worry about that. Yeah. So now, no, sorry, this is dx. Where there's a p to y. This is a p as a relation of y. We do this as a y as a relation of x. Okay. Yeah, this is x. This is x. So log y equals minus cx. What's y? What's cx when you do a log y? What's the cx left?
It's the power.
The power, yeah. So y equals to e to the power of cx, right?
Yeah.
That when you take a log, this comes down, right? That's just a log,
Oh.
right?
Sorry, I thought it was like log log. Got confused.
This is
Yeah,
this
I know
is
the base is
ba-
E,
yeah,
yeah.
e based, yeah. That's what because right. That's because the base, right?
I know,
when
I
we
know.
say this equals that, yeah.
I
it doesn't
know.
matter. The constant is just the constant comes from the base change. When you change the base, the c changes.
Yeah, I know.
Okay, x still x. It wouldn't be like x squared or something. Yeah, and this is important because this is you know what that function look like?
It looks like this.
Yeah, right, exactly. Of course, yeah, it here's 1, right?
Yeah.
Yeah, from 1 on is it goes to like this. Here's 1. Yeah. Okay. In other words, as the y goes, yeah, that's the problem. Because the y is I make it pointing down. In other words, when y goes, this is a negative y actually. When y goes up, p goes less. When y goes down, p goes down, but my y is the other way. So this actually, when you plot it, is this way. But anyway, that's I got punished by doing this. I should have the y pointing up. I got the y pointing down. So that's counterintuitive. But in any case, this is a very important relation on in other words, this is a very important equation.
Yeah.
A lot of things are like that. Let's just take a little more look at this. Let's drop the c. C could be anything. Doesn't matter, right? We just look at dy paper. We just look at dy dx. dy dx equals to minus x. Okay, we just look at this. What's the point of this? Okay, what's going on? Okay, any place, right? For instance, here x equal to 0, dy dx x equal to 0, dy dx is x is 0, dy dx is
0.
0. Yeah, actually anywhere, right? dy dx is 0, right?
Yeah.
Anyway, I mean any curve that goes through this is 0, right?
Mm-hmm.
When x equal to 1, what's dy dx?
0.
X equal to 1, this is dy dx is 0. When x equal to 1,
Oh.
what's this side?
-1.
Yeah, so what's dy dx?
It's x to the power of -2 divided by 2.
No. Look at this thing. Look at this equation. When x equals to when x equals to 1, what's dy dx? -1, right? This is the equation. It's not a rule. You know the equation?
No.
Y equals to x plus 1. Y doesn't have to be x plus 1. Y could be anything, right? But I'm giving you an equation, so y equals to x plus 1. You get my point? This is an equation. It doesn't have to, but in this case, it is. So when x equals minus and when x equals 1, what's dy dx?
Anything?
Minus 1. They equal. When this is minus 1, what's this? They said equal by the equation. Get the point?
Not really.
Okay, this is the equation, right? When x equal to 1, what's y?
2.
When x equal to 1, what's dy dx?
2.
2. How do you get that? This is two different equations.
Oh.
When x equal to 1, what's dy dx?
-1.
Yeah, they equal. They make it equal. This when x equal to 1, right? This equation makes y 2. This equation makes the dy dx minus 1. See that?
So, okay. I understand it, but
Okay.
I don't see the point of this whole
Okay.
thing.
Okay, look at this, okay? So at here, this is the x equal to 1, right? So it's minus 1, right? Minus 1. You're going to see the point, okay? So when x equal to 2, what is it? Look at this.
-2.
-2, yeah. Steeper, right? Steeper. Right? Steeper, like this. And of course, when x equal to minus 1, it is
1.
1, right? I'm drawing this thing to this is more like 2. Okay? 2 is steeper, right? Right? So this is what that equation tells you. Any point, right? This is a slope.
Yeah.
So in other words, if you're going to start, if you know a point of this equation, you're going to know the shape of it, right? It's going to go down this way, right? Because that's how this thing gets connected. If you know one shape of it, you're going to know the shape. If you know one point is on this equation. Because all the differential equation could be anything. Because when you take an integral, there's a constant got introduced.
Yeah.
That's a constant. In other words, any kind of differential equation, right? The solution would not be certain, right? Because when you take an integral, there's a constant.
Yeah.
Look at this. This is the vector field. Whatever. This is actually not a vector field because there's only a direct. It doesn't have this direction, that direction, but it's a slope. Okay. Look at this field. This is when you have a. We said that when you have a equation, you need to have a picture.
Yeah.
This is the picture of this equation. In other words, let's give you another one, right? dy dx equals to, say, x plus y, right? That will make it, this time, let's get smart, yeah? This is the 1 and 2, right? 1 and 2, okay? When, at this point, x is 1, y is 0. What's the slope here?
1.
1, right? About this. A 0, what's the slope?
0.
Yeah. Minus 1, 0.
-1.
Minus 1. Minus 2, 0.
-2.
Minus 2. Minus 2 is steeper, right? Like this. Yeah? And 0, 1.
1. -1.
1. No, 0. Oh, 0. No, yeah, you're right. Okay. -1. See, this thing actually connected up, right? 0, 2. 0 minus 2.
-2.
-2. That'll be like this. Wait a minute.
That's wrong.
Oh, this is yeah. This -2 goes this way. Yeah, and this is plus 2, right?
Yeah.
This no. This is the 1. So this is plus 1. This is plus 2. Okay, this is plus 2. This is 2, 1, 1, right? This is plus 2, right? This point is plus 3. This is steeper, and this point is let's get these points. This is minus 2, right? Minus 2 is like this. This is minus 3. This is minus 3. This is minus 4. Something like that, right?
Yeah.
In other words, you can see this number comes in here and then start to flip up. Yeah? So in other words, if you know your initial point is here, right? you know this is going to go along this way, and then somehow it'll go back up.
Okay.
So this is how you imagine this. Yeah. At every given point, there's a slope. That's what they're telling you. This is the slope at any given point. This is the slope of it. When you have every point you have a slope, it's something look like this. You go to the internet and they have a nice picture of it. They have things spread out, like all of them. I just don't have the, well, this is the wrong number to draw anyway. Probably you want to draw half of y or something. So this is flatter and then goes deeper or whatever, right? But you get the idea, right? This is, when you have an equation that has a derivative in it, you're looking at this. And the other thing we learned is if the equation is dy dx equal to minus x, it's exponential. The x equals to, y equals to e to the minus x, and it goes down. Okay? Radioactive decays, okay, the radioactivity by time, right? Right?
Yeah.
Is proportional to the radioactivity itself. Same thing. What other? Oh yeah, making money, right? Making money actually at any for every year you make 6%, right? So dy dx dt, let's say t, right? It's 6% equals to 6%. Well, 1 plus 6%. Okay. Well, this is actually not a dy dt situation. Okay. This is called a delta y. Yeah, delta y delta t. This is the money, right? Equals to 1 plus 6%. Okay. T. Money. That's y, right? This is how much money you have. You
Yeah,
make.
Then you put the power for every year. Like this is the principal amount, right? And then
This is the principal amount, and you make 6%. Then that's how much you make.
no,
per that.
but then don't you put the power of like time over here or x? So like